Okay, this is a supplement lesson to lesson 4, and basically it's the same concept, but we're going to use two different chemical reactions compared to the formal lesson. So the first example is another exothermic reaction. And this one in particular is what happens when we dissolve calcium chloride, which is an ionic solid, in water. And we're going to end up producing calcium ion, which is dissolved along with the chloride anion. Now, since this is exothermic, what that means is that energy is released. So technically speaking, we can actually write the energy in as part of the equation. And since it's exothermic, the energy is being given off, so I would write energy on the right side of the equation. All right, now, several videos ago, we talked about compositional potential energy. Composition. Potential energy. And this has to do with the energy change that happens when bonds are broken and reformed, as opposed to like melting an ice cube or something. So I want to set up a visual for this. So we have a big glass of water here. And this represents the surroundings. And then inside this is where we're going to place the calcium chloride so it can dissolve. So I'm just going to make a big fatty box. And this is the system. So this is our CaCl2, which dissolves to make Ca plus 2 plus 2Cl minus, plus energy. Now, let's just talk about this compositional issue. So the calcium chloride is an ionic bond. And in this reaction, we have to actually break that bond up. We're going to break the ionic bond, and then new bonds have to form over here to between the calcium ion and water. That's what the excess business is. That's what the aqueous business is about. So there's a difference in compositional energy between this ionic bond here and the bonds between the ions in water. So over here we're going to have bonds, water, plus ions. Now, I'm going to write a bracket here. So for the two ions, the bonds between the water, this represents a new potential energy of the products. What's not addressed yet is what this is in particular here. So this energy here that's also produced as a product is in the form of kinetic energy. So I'm going to write plus Ke. So in the compartment down here, when this reaction occurs, we have our two products which represent a new potential energy. And that potential energy is actually less than the potential energy of the reactants. The difference is right here. So on the product side of this, we have the sum of these two things, which has to represent overall the energy that we started with in the reactants at the very beginning of this thing, the sum of these two values. So that kinetic energy that gets released here, right? Remember that we have the sum of these two things. We have the sum of the potential energy of the product plus the sum of the kinetic energy that is released. That when you add these two things together, you get back to the total energy that we started with in the reactants. Well, this kinetic energy is going to be transferred from the system into the surroundings. Okay, so I just complicated my example. And the reason that I did is because this kinetic energy is going to move. So I'm going to pull this positive sign right now, because it's going to be transferred from here to the surroundings. All right, now how do you know this is happening? Because at the beginning of the experiment, before you've added any of the calcium chloride to the water, if you're holding that glass of water, it's at room temperature. It's not going to feel really much different than the temperature of your hands. It's going to feel like there's not much of a temperature difference. But once we add the calcium chloride into the liquid, then what's going to happen is the kinetic energy that's being released is going to move into the surroundings, and the temperature of the surroundings is going to go up. And in fact, for this reaction, the liquid is actually going to become pretty hot. Like if you're holding on to the glass, you're going to go, man, this is really warming up. And truth of the matter is, if you added enough of the calcium chloride to a small enough amount of water, you could actually get the temperature of the surrounding liquid to nearly boil. So if I was to draw a graph of this, and I'm just going to arbitrarily assign the vertical axis as energy, our calcium chloride is going to fall somewhere on that axis. And then after the reaction's over, the two products are going to be lower down in here. This is the hallmark of an exothermic reaction. All right, and if we were to, so this is another way of looking at this. If we were to draw lines out like this, so here we're going to have, this is the energy at the end of the products. And this is the energy, whoops, this should be E2. And then this is where we start with the reactants. So if we were to take this difference here, this is going to be the kinetic energy that entered the surroundings. That's what this is. And that's why the surroundings heat up. All right. Now, very quickly, we're going to move to the opposite example on a different page here. And in this one, we're going to look at what happens when sodium chloride, and hopefully most of you will recognize this as table salt, dissolves in water. So for this particular ionization reaction, it is the opposite of the one that we just looked at. So for this one, it's going to turn out to be endothermic. So we can write energy on this side of the equation rather than on the product side. So this is the alternative possibility. So this is an endothermic example. All right, and again, if we build our universe, so we're going to have a glass of water again. And on the inside here, just as as an illustration, here's my system. Here's the surroundings, which would be the water. And we move the sodium chloride inside the box where it ionizes. All right, and again, think about the composition here. We have a strong ionic bond between the Na and the Cl, and then over here, composition-wise, this is bonds between ions whoops, ions and water. So we've switched the platform. We've gone from a strong ionic bond to literally ions that are bonded to water molecules. All right, so we have a difference in composition. The main issue with an endothermic reaction is that energy input to drive the reaction, in this case, the reaction actually has to be driven. Like, you know, turning on a car and burning gasoline to push the car. In this case, we need energy to actually break this ionic bond and transition to the other possibility here. And the way that happens, the source of that energy has to come from the surroundings into the system. That's where the energy is coming from. It's coming from the surroundings into the system. All right, and that is what is driving this reaction. Because in this case, the change in composition is not the same as the previous example. In other words, the products here are going to be at a higher potential energy. So the potential energy here of the products is going to be greater than the potential energy of the reactants at the end. So if I was at the end of the reaction, so if I was to draw a graph here, it's going to look different than the previous example with the calcium chloride. And I'll just pick an arbitrary place to put the NaCl. And this is going to be E1. And then the two products are going to be at a higher energy. And remember, the reason they are is because of the bonding to water. So here we've got our two energies, so this would be E2. And you can see that when you take the difference here, so this is going to be the potential energy. Well, no, wait, I want to be consistent with the last example. So this is going to be the input of energy here. So this is going to be your plus Ke. And it is going to be the difference between where we finished with the ions bonded to water versus where we started with the Na bonded to the Cl. And this thing right here is lost from the surroundings, right? The energy to drive this reaction is coming from the surroundings, right? And that is shown here. So energy is moving from the surroundings into the system, and that's what drives the reaction to form the bonds between the Na plus and the Cl minus, and or the Na plus and water and the Cl minus and water. All right, and with that, I'm going to go ahead and conclude the recorded portion of the video.